Hey there, Jason. So, what I wanted to show off a little bit today is how I built an AI research assistant in Claude Code. I have a specific sort of area that I do some research in, which we'll get into in a moment. And the research takes, frankly, a long time to do. And I wanted to try to figure out a way that I could use the power of stochastic parrots to accelerate that research. So,
Nice.
would you like to dive in?
Yeah, let's take a look.
Right on. So I work at Datadog, and among many of the things I'm interested in is software supply chain security. It's a fertile field, and it's got a lot of layers and a lot of depth, a lot going on. And the area that I was particularly interested in was understanding package repositories like PyPy or NPM or what have you, right? I want to understand their security posture, right? These package repositories are de facto part of your security perimeter. If you're pulling packages from them, you should know how are they protecting themselves from attacks and vulnerabilities and exploits and so on and so forth. And that's what I wanted to do some research on.
Okay.
So I built, a research assistant, but the research assistant does a very specific thing. Is it tries to find answers to questions. I know that sounds very straightforward, but there's some subtleties there, right? So to give you an example of what it is that we're looking at, this is the software supply chain security scorecard. So right now I've got about 52 questions organized across some different sections. And they start with some things that are pretty straightforward, like does the source enforce multi-factor authentication, right? Does the source enforce identity federation, and so on and so forth? And sometimes the answers to these questions are quite straightforward, really much, very much a yes or a no. And sometimes they can be a bit vague. Sometimes what's in the documentation and what's actually enforced or what's actually in the code don't quite line up. So in order to do an assessment, it would take me upwards of a day and a half, 2 days against a given target to do properly. And I thought maybe the LLMs could help me with this. So we're going to dive into what I ended up building to help me accelerate this research process.
Nice. Okay.
Yeah. So we'll take and go back to the terminal. Here we are. So basically what we've got, and as I mentioned earlier, it's in Claude Code. So we'll take and start right inside of Claude, right? We'll go to the skills, and there's a number in here, but the two that are interesting to go through today are the assessment and the starter kit. Basically, when we're doing the research on this, I have to figure out where to do the research. Where are the official documentations? Where are, the RFC system? Are there any official blogs? Are there any unofficial blogs? Where are the weird underground, Discord forums, et cetera, that are going to help me go through this? And sometimes I can find stuff right in the docs. Sometimes I can't. Sometimes I got to look in the code as well. So the first thing I wanted to do was start with what I call a starter kit. And the starter kit is very, very simple. The idea is to build an assessment starter kit. And in it, we'll say, what are the authoritative source URLs to search for, RFC proposal acceptance criteria, pre-answered questions, because sometimes I already know the answers to some questions, and I don't need the LLM to go figure it out, right? It's fairly straightforward. So the skill here, very, very simple. And then if we take a look at the assessment skill, this one here, again, is just the entry point. So I can do assessments. I can do a full run across all 52 questions across only a given section. Say I'm only interested in understanding the auth section, or I'm only interested in understanding the provenance and integrity section, or whatever. And then from here, I can, you can see here that there's 2 bits of output. And these 2 bits of output, which we'll really, really dive into here in a second, because they form the meat of this, but it's important to say out loud. The first one is the scorecard. This is the actual output of the answers to the questions. We'll get into that in a second. But before that, they also built something called a runtime. And the runtime is as you can see here, the full evidence trail. So what I was looking for here was to understand the LLM's behavior. What is the decision-making chain? Where did it look? Why did it come to the conclusions that it came to, right? What sources was it drawing from? How many sources did it try to draw from before it reached that conclusion? And this is basically my way of attempting to understand how the LLM is operating. Sometimes the LLM finds the answer real quick, and it's really, really confident about the answer, and it's wildly wrong. We have to understand why, right? And that's the approach there. But of course, skills are just skills; they're entry points, right? What's interesting are the agents, because the agents are what are doing the actual work. So if we take a look here at the starter kit builder, this is a standard agent for Claude Code. So it starts at the top, gives a name, gives a little description, right? Builds and maintains starter kits for the registry assessments. This uses Sonnet is the model. And I know Sonnet's not the newest whiz bang, whatever. You might be thinking to yourself, oh, Sonnet because it costs less than Opus. That's true. But in fact, in this particular case, I found that Sonnet was more efficient at this particular task. Opus really likes to overthink things, and you can use that to your advantage. But in this case, I didn't want it to overthink things. Haiku could probably do this, in fact, because really what I'm looking for here, and it says right here, this is a source configuration tool, not a research tool. Your job is to identify the right URLs to search and to capture user-supplied knowledge that can't come from public research, right? We define a simple schema for the starter kit. So where are the sources we looked at? Where are the RFCs? What is our search config? If there are any pre-answered questions, right? Then we walk through here, what's the setup? So when we're building the starter kit, we create our assessment, we check to see if there's any ones that exist already. I realized I'm now showing this in BAT instead of GLOW. My apologies, but now you've got BAT on screen. So we fetch the registry's homepage. We look through some obvious paths, right? We give it some hints, okay? We block some patterns around user and package content, so on and so forth. And then we submit that all in and write it out and ask the user, does this look good? And call it a day. Now, you may be thinking to yourself, why would you bother doing all of this, right? Couldn't you just can you just say to the AI, here's 52 questions, go and answer them? The answer is no. You cannot do that. That will fail in fun and disastrous and interesting ways. And that's one of the things that I discovered when I built this, because it actually took me a while to put this all together, was that non-determinism is an antagonist, right? So LLMs really want to answer questions. They really want to do a good job, and they really want to produce results that you will be happy with, even if those results are completely fabricated, completely wrong, right? And it's fine. So what you have to do is figure out ways to keep it on rails. And this was the first step into keeping that research on the rails. Give it explicit instructions. When I start to sort of treat the LLM like I would actually, if I had, say, a group of interns, right, working on my lab, and I would just say, hey, group, we're trying to accomplish this really large, high-level goal. Not everybody here is an expert in all aspects of it. So what we're going to do is we're going to break the work down into sections and have really specific instructions for each of those sections. And that's effectively what we're saying here, right? Take the time at the start to set up the schema, to set up the instructions, set up what you're looking for, and that's going to pay dividends down the line. We have some behavioral principles here. This took me a little while to figure out as well, is because we actually have to tell the LLM how to act, right? The LLM will do a lot of inference. It will try to look at its own answers and draw conclusions from that. And I don't want it to do that, right? I'm giving it specific information and asking it to come up with specific answers. And again, this is not even the research part yet. This is just the starter kit. Never invent sources, right? That's super important, right? Never invent sources. This is so clutch, because in fact, I noticed when I was doing this that it would invent sources. So this brings us to the actual assessment tool. And the assessment tool is what's interesting. This is the autonomous registry assessor. So it takes and it researches and tries to answer these 52 questions for a target registry. And you can see here the model I chose is Opus instead of Sonnet or Haiku. And you think to yourself, wow, it's Opus, it's the greatest model until the next greatest model comes out. Obviously, Dan, you want to use that model. But there's a reason. The reason is because in the way that Sonnet is very good at driving directly at things using the path of least resistance, right? It'll get it wrong, but it'll do it. Opus likes to play with language, right? Opus likes to fool around with different ways of asking questions. And this can be problematic, but you can use it to your advantage. And I end up using it to my advantage here in the research tool. So with this, and you know what? Instead of doing this in Vim, we can look at it in Glow because it's prettier. This is what I want it to show. Haha, nicer, more readable. So the mission, I give it a mission statement. Again, just like I would give a mission statement to, you know, a group of researchers or a group of interns, right? Answer all these questions. Produce that runtime evidence file so that I, the human, can understand how the LLM's operating and iterate on this model and make it better. And of course, produce that final scorecard. We can give it some arguments, right? So parse the sections, questions, filters. You'll notice here, and this is very important, that I actually have it called JQ, as opposed to letting Opus or letting Claude Code do the JSON manipulations or the JSON inspections. I say, don't do it. You have a system tool that's designed for this. Use JQ and just read the results. Why? Again, because the model will confabulate. And it will get subtle things wrong. It will invent a string, right? Little things like this that break the research flow. So again, non-determinism is an antagonist here. Anything you can do to remove that non-determinism, to add determinism, you want to do. And guess what? We've got multiple decades of tooling that we as professional computer touchers have come up with to provide deterministic answers to questions based on data. Use those, right? They're your friend, right? So here we can invoke it, and I've got some instructions on how to use JQ, right? Don't invent how to use JQ. I'm telling you how to use JQ. Use it this way, right? And then we can go through and I give it a runtime file schema. This is important. Do not be afraid if you have a specific way you want the data to be structured to tell it that, right? Be specific. You don't have to know how to make good schema files, right? I'm not very good at making schema files, but the model is good at making schema files. You tell it what's supposed to be in there and it will generate a schema for you. And then you just plop that in and it's the same every time, which works really, really nicely, right? Another advantage of schema file is that you can use, again, deterministic tooling, of which we have a lot, to compare the output to the schema to make sure the LM didn't make any mistakes. Really nice, right? So trust but verify really is the whole of the argument here. And we've got some descriptions about what the status fields look like. How do you get to the status fields? Are we asking the question? Is the question yet to be asked? Has the question been answered? Right? And this is because when I was building this as a tool, I found sometimes it takes a little while for these assessments to run as normal, right? But I'm running it on my laptop. Sometimes I got to close my laptop and walk away. And what happens when I do that? Well, a lot of things happen. But one of the things that happens is the search stops. I have to be able to resume it deterministically from the source, right? Don't let the model try to figure out what has already done and not done. Use the runtime file to have a 100% understanding of what has been done and what hasn't been done and what is yet to be done, right? That's super, super important for, again, making this a deterministic tool that I can trust. We give it a startup sequence. And again, I'm explicit about this, right? Don't let the LLM try to guess. Give it specific instructions. For anything that is repeatable, in fact, you could just put this probably into like a little shell script or a little Python script or something like this. My startup sequence is very, very straightforward. It doesn't trip on this in my experience. If your startup sequence gets any longer than this, you might just want to script it, honestly, right? I give it some instructions about how to loop through the different sections, authorization, access control, so on and so forth. And again, this is just me talking to an intern and going, how do you answer these questions? Do you answer them in order, right? Like, how do you write out the resulting files? And then we start to get into how do I want it to behave? Not how do I want it to operate, which is a lot of what we've been talking about so far, right? What are the guardrails? What are the rules? What's the order? What's the sequence? What are the things that I expect you to be able to do that are rote, that are repeatable? But now we start to get into what are the behaviors. How do I expect you to think? How do I expect you to reason? How do I expect you to understand the problem and to respond to that problem? And this is where, in my opinion, it starts to get interesting and where you start to see the biggest variations across models. The way this worked, for example, in Haiku is that it didn't. The way this worked in Sonnet is that it drove really, really fast at the most obvious answer. And if you were lucky, you got it right. The way it worked in Codex and the different models that it provides, again, they all operate differently. I mentioned at the outset that Opus likes playing with language. And this is where understanding the behavior and the natural inclination of the model becomes important, because you don't want to be working against it. You want to be letting it work for you.
Yeah, I think that's
Here we have
very important distinction.
It is. It's a super important distinction. Precisely. I spent a long time fighting models before I figured this out, right? And I suspect a lot of people spend a lot of time fighting models before they figure this out, right? So start to get into the behavioral questions. Here I say, if any of your questions are pre-answered from the starter kit, then just use those pre-answered questions. Don't re-research, don't reinterpret, don't modify any of the fields. The starter kit's authoritative. You need to say this out loud, right? The LLM will not guess this. Then we get into stuff like evidence gaps questions, right? And how we get into what are the standard research? How literally do we effectuate the research, right? And this is where we start to get into using Opus to my advantage. So I would have it ask the same question in 3 different ways. So for example, if my question is, does the source enforce expiration on API tokens, right? That's an interesting question. I would have Opus produce 3 variations of that question from 3 different angles. A direct phrasing of the question, so the question itself, right? A synonym-heavy rephrasing of the question. So the same question, but using all different words, right? And then a different aspect or an implication of the question. And this third one here is very interesting because this is where you can let the LLM kind of rub a little magic on it, right? Where I said before that non-determinism is an antagonist, and it is when you're trying to get it to be repeatable, which is all that preamble. But here is where you can go, I want you to ask this question in ways that maybe that I never thought about asking it. And that's where that insight comes into play, right? We can leverage the power of the large language model to our advantage. And then in step 2, we go, what are our primary sources? So what I'm interested in is mostly primary sources, right? So for a given domain type primary source, so there's a homepage or a documentation root, right? So I'm looking for official documentation, official homepage. I want you to run those 3 queries across that. And you have to run all 3. This is important because if you only run the first question and you think the answer is no, well, maybe it's no, but maybe it's not. That's why I asked the question 3 different ways. Similarly, if you ask the question and you get the yes answer, are you sure about that? Again, that's why I'm asking the question 3 different ways, right? Where we said at the outset, the LLM wants to be helpful. It wants to answer questions. This is a way of ensuring, or at least moving us towards an assurance, that the question is actually being answered, not just guessed at, right? And we say here, we want only primary sources, directly read the page content. We're looking for evidence, not confabulations, right? We look through RFC sources if the target has RFCs, because sometimes answers will be in documentation, but the documentation's out of date. And the RFCs are actually more up to date, or the RFCs contain details about the answer to the question that the documentation doesn't. It happens all the time. Open source, love it, right? So we look through this, and again, we're looking for merged and accepted RFCs as strong evidence of a commitment that it was implemented. But here the wording is very important. It's strong evidence that the commitment was implemented. It's not necessarily evidence that it's true. Right? And this is why we say ask the same question 3 times and look through multiple sources before you attempt to answer yes or no, right? Look through those secondary sources, right? Look through blogs, look through the social media of the people that maintain the registry, right? And then as a last ditch, we couldn't find the answer to the question definitively, search the open web. I really try to avoid getting this far. And in general, when I look at the runtime file, if it got this far, it means something went wrong, or the documentation really just does not address the question at all. In which case the answer is no, right? Because the thing I'm looking for just simply doesn't exist. But the lack of reference to it, the LLM doesn't understand that to be a no. It just understands that to be, I haven't answered the question yet, right? From all of that, we can get to our final step, which is to determine the answer. And the answer has to come with populated notes. So 2 to 3 sentences written for a human reviewer, in case that's me, right? It has to include direct quotes from source material that prove, we'll put this in quotes, support the evidence that the answer is either yes or no. In extremely rare cases, we will come across unknowns. And unknowns sometimes happen when you have contradictory evidence, where documentation explicitly says one thing beyond the shadow of a doubt, but the code base says something else entirely. Then we have also discussion here on evidence standards. And here is just, again, behavioral, right? How to interpret language. When I say enforce or require or mandatory, what does that mean? And how is that different from support or can or available, right? Is MFA supported? Is different from is MFA enforced, right? And this one here is super important, and I do like to point this one out. Ambiguous evidence means keep searching. Don't stop. It means keep searching, right? The LLM wants to stop. Don't let it, right? Just like you wouldn't stop if you didn't have an answer. You would keep going until you had the answer you were looking for, right? Quotes must be content from the source, not a description of your own search process. Boy, does that one sound weird? And yet, I've found multiple instances over multiple iterations of building this, where the LLM would confabulate its own search process as an answer to the question, believe it or not, right? And this was actually true across multiple models. So we have to say, hey, don't do that, right? And the only way I found all this stuff was because I had that runtime file. I had it spit out every decision it was making, everything it was looking for, every single page it looked for, every conclusion it drew from that page. And I was able to spend time understanding the behavior and functioning of the model for this problem set, and to provide these rules and these behavioral guidelines to, again, to work with the model, not against it. Finally, we get to the stop criteria. And now this is important, because in the same way that the LLM really, really, really wants to get to the answer, we've spent a ton of time here telling it not to stop. Don't stop, don't stop, don't stop, don't stop. Eventually, it's going to have to. But we have effectively at this point given it the behavioral incentive to never stop. This is its own problem, right? Because it will just spin off forever if you tell it to, right? Until all the tokens are exhausted and there's no more memory and I've spent hundreds of thousands of dollars, right? Eventually it has to stop. So you have to give it what are the criteria for stopping. And the criteria are very, very specific, right? Once you've exhausted the sources, once you've done your maximum open web searches, then you can stop. There's a little around taskless behavior. It's not that important. A little bit about how to generate, the scorecard. This is just very, very specific to me, how to use JQ. And then ultimately, file persistence, right? Which is just so it doesn't thrash the disk as it's doing it. And that is effectively how I built an AI research assistant that I can trust. Now, the last thing I want to say about this, and I think this is important to say out loud, right, is that this will get, of the 52 questions, let's say 48 of them right the first time, generally speaking. That's a number, right? But let's say there's 5 or 6 questions per registry that it just doesn't quite get right the first time. And so and how do I know that? Right? Without actually having done the research myself, the question is, how do I know that it got some wrong? Right? The answer is I run each of these assessments multiple times. So I don't let it, I run assessment and it spits out an answer after a certain period of time. Sometimes it'll be as short as 15 minutes. Sometimes it'll go for 30, 45 minutes, right? And then I run it again. And then I run it again, right? It doesn't bother me, just let it run. Those 3 assessments in general will have the same set of questions with the same answers every single time, but there'll be a little group of them where they flip back and forth between yeses and nos and unknowns, yeses and nos and unknowns for different reasons. But that to me is the signal that the LLM couldn't figure it out. And then me, the human, I can go, those are the questions I need to answer, right? The other questions, they were obvious from the docs, they were obvious from the RFCs, they were obvious from an analysis of the code base itself. I'm willing to trust those, right? But the ones where it flipped back and forth or couldn't get to a conclusion and reliably flipped back and forth, reliably could not get to the conclusion, that's on me. I got to go find the answer. And then that's what I put into the pre-configured startup kit. So the next time it doesn't have to do it.
Nice. Yeah, I love this. When we were talking about this before the recording, kind of taking this non-determinism situation that we're all in now, and trying to get it back into this binary situation that we grew up with and understand yes and no, and like how to build systems that are repeatable and sustainable and operational and blah, blah, blah.
Yep.
Non-determinism brings in this whole level of behavioral, analysis. And, we use words like guardrails or harnesses or things that, even if it's a technical term, mentally it's meant to like create the mental model of you have control of these things. And that's actually also a kind of a false mental model, I think, in most people's experience when they're trying to get an AI to give them something. But what you've done here is you've been so explicit and prescriptive and thorough. It forces it to do, this binary decision tree thing, basically, where it's also creating accountability, which is another aspect of this. I think your sort of research background has forced it to like analyze itself, and you've analyzed it to like create the next step in the evolution of how do we work with the antagonist rather than, because the other part of this is that to your point, the different models, they behave and do different things, and they're all pretty good at gaslighting. Others are better at others, and they will go to levels, the depths that they will go to sort of convince us that, what they've done is the right decision.
Yeah,
And
right.
And, thankfully, I think many of us do have enough experience to be able to know better and say no, and so that's led us to this point where you've developed a whole, thing. It's beyond a guardrail, a thing. Also, we should point out you've done this in the sandbox, I believe, right? You're using Nono or something to help sort of
Yeah,
keep
I'm
things.
using Nono for this, right?
Yeah,
Because and that's actually important to point out because this is effectively just going on the open web and downloading HTML and parsing it, which is dangerous,
yeah,
right? And so I run everything inside of Nono. Nono, if you haven't seen it before, you just go online, just search for Nono Sandbox using your favorite search tool. And it is an OS level sandboxing tool that you can use to wrap anything you want, period, right? It's not specific to LLMs, but it came about as a result of the rise of coding agents and agentic behavior, right? So it has a profile for Claude Code built in, and has profiles for other ones built in. And instead of just being suggestions, like, hey, Codex, please don't reveal my SSH keys, okay? What it does is it actually uses your operating system's sandboxing tools, so kernel controls, file system controls, so on and so forth, to run whatever, in this case, the Claude binary, such that even if it decides it wants to download some poisoned prompt from some weird part of the internet, right, and run it, and that poison prompt goes, yeah, okay, download and curl bash this and set up a Bitcoin miner. Well, it'll try to, but it can't because it'll actually be blocked at an OS level. It's pretty sweet,
yeah,
actually.
yeah. And I think finding that autonomous agency that we want to give the agents is what we're after. But
Yeah,
it's delicate. We don't want you can't let them take too much control, or not control, but just give them too many things that they're capable of doing,
yeah.
and in the wrong scenarios. So, all right, well, Dan, thank you so much for sharing all that. That's awesome. And look forward to hearing more about how that progresses over time. So we'll talk
Thank
to
you
you
very
later.
much. It was really fun. I appreciate you inviting me on, and happy to come back another time to show how it's evolved.
All right, sounds good. We'll talk to you later. Bye.
Cheers.